Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about the sun is on fire, and of course, taking listener questions about all things in this amazing universe, because that's what this show is about. We record every Thursday at 8 p.m. Eastern, so you can follow along online or leave a voicemail at spaceradioshow.com. And in today's Blue Shift, I'll be talking about let's launch a book into space and the National Society of Black Physicists. But first, the news. Hey, Space Cadets. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Stony Brook University and the Flatiron Institute. And for the next half hour, your Agent of the Stars got an exciting show for you today where we talk about all the amazing things in this universe. This show lives on listener questions. We record every Thursday at 8 p.m. Eastern here in Spaceman Studios in New York City. So leave a voicemail over at spaceradioshow.com to get your voice on the air, or you can join our Space Cadets tuning in live from around the world, including, but not limited to, Germany, Chicago, Illinois, New Zealand, Arcata, Northern California, Washington, D.C., Palisade City, Alabama, London, UK, Houston, Texas, Urbana, Illinois, shout out to my alma mater, University of Illinois, Halifax, England, Denver, Colorado, Marysville, Washington, and Redmond, Washington, and many places others from around the world that I did not write down on my little note card. Oh, some are coming in right now. Howell, New Jersey, and Fayetteville, Arkansas. That's great. See, look, people are tuning in live from around the world to watch me make up answers to your burning space question. I don't make up the answers. Okay, like it's real answers, but I don't know what I'm going to say. Seriously, folks, I've only pretended 10 minutes to show material top, so get those questions in. Space Cadets, how are we doing today? London, Canada. I see you. Don't worry, I see you. We got lots of cool news. Say yes, a lot of you are asking about the 36 alien civilizations. Maybe I'll pivot to that in the news, but then we will we'll do it. We'll do whatever we want, right? Because it's our show. Well, it's my show, but it's our show, except it's my show. But we do it together, but mostly me. Before I start taking questions, I want to share some interesting bits of news I caught recently. And wow, there's a lot going on with the sun this weekend. First off, there's going to be an annular solar eclipse. This does not mean it happens annually. That's a different word. This is annular. This means it's like a total solar eclipse, only less so. It's because the moon happens to be too close, so it's not going to completely block out all the light of the sun. It's going to leave a little ring around the edges, so you get this cool ring of fire effect. It's not the awesomeness, the pure awesomeness of totality, but it's pretty sweet. So if you happen to live in Central Africa, the southern part of the Arabian Peninsula, or Central Asia going into India and China, you are in luck. I believe it's this Sunday, stretching all day from Africa to China. If you don't live in there, it's going to be a normal Sunday. It's not going to feel any different at all. Speaking of the sun, set to launch soon they've already launched it back in February. The European Space Agency launched their solar orbiter, and it's scheduled to take its first experimental data pass this weekend. It's currently sitting about 77 million kilometers from the sun, about half the distance between the Earth and the sun. This guy's not going to get as close as NASA's Parker Solar Probe, but they're actually designed to work in tandem so that the Parker Solar Probe is going to get closer to the sun, but it doesn't have any imaging capabilities. It doesn't have any cameras. This mission, the Solar Orbiter, won't get as close ultimately as the Parker Solar Probe will, but it does have lots and lots and lots of cameras. So look next week for some really sweet pictures of the sun. Seriously, if you have never seen a picture of the sun before, you really should. from here on the surface, it looks like a nice, calm, steady orb. But once you start looking at pictures of it, it is awesome. There are prominences, there are flares, there are ejections, there are granules, there are sunspots. The surface of the sun is one of the most chaotic, if not the most chaotic place in the solar system. And this, I'm telling you, I'm calling it right now. The ESA Solar Orbiter is going to be responsible for more nerdy desktop backgrounds in the coming year than anything else. I'm calling it. I feel very confident in that call. Speaking of being confident, I wasn't going to hit this in the news, but a lot of space cadets are already asking about. There's this news story circulating around about this news report, this research study that claims that there are 36 and exactly 36 or as few as 36 alien civilizations in our galaxy alone. So we are not alone. There are 36 others. I'm going to take a deep breath. We're going to focus. We are going to relax. Yes, it is in the news. Yes, it is all over the place. Yes, I will talk about it now. You convinced me, Space Cadets. You convinced me. I was going to go to a caller, but I'm going to save the voicemail for later because I really want to talk about this because it's... We can do it. We can do it together. It's just I need a moment to collect myself. Are you guys ready? I'm ready. Normally, this is the part of the show where I take a voicemail and answer it very excitedly. And if you only hear my voice, you don't get to see all of my arm movements and bodily gesticulations that are involved in my responses. You should go to YouTube to check that out. I will do a voicemail later, but the Space Cadets have been asking about this news story, and it's in the news, and it's a question. People are curious. Okay, you may have heard on your local news station or newspaper that scientists have now figured out that... This is the voice of scientists, by the way. That there are 36 alien civilizations in our galaxy. I'm going to say a couple things. One, I've not read the paper. So disclaimer right out there, out of the gate, I didn't even bother reading the paper. Does that make me a bad scientist? Does that make me a bad science communicator? Probably. Does it make me a lazy one? Probably. Does it make me wrong? No. In what I'm about to say. Because all these papers that claim that they have an estimate for how many alien civilizations are out there are making it up. They're just making it up. They're just making up a number. Yes, they're doing it in a very, very fancy, complicated way using something called the Drake equation. The Drake equation is not an equation. It's a way of guessing how many aliens are out there. So you start with a guess, like, okay, how many stars are there? Okay. How many planets are out there? Okay. Of those planets, how many have liquid water? Okay. How many of the ones that have liquid water, how many of those have life? Okay. One of the ones that have life, how many of those gave rise to intelligence? Okay. And of those, how many of them are potentially communicating that we could potentially reach out? Okay. That's the Drake equation, or a version of the Drake equation. We have a rough estimate of how many stars are in the Milky Way. We have a ballpark estimate of how many planets are in the Milky Way. It's somewhere between 300 billion and 1 or 2 trillion. It's not too bad. It's better than the guess we had 10 years ago. How many of those are Earth-like or have liquid water? We've got no idea. How many of those have intelligence? We have no idea. How many of those gave rise to life in the first place? We have no idea. We have no idea. So you just, what you do in the Drake equation, and every time the Drake equation comes up, I say exactly the same thing. Every time you do, you just plug in numbers, starting with what you know, and then you start plugging in a bunch of stuff that we don't know, and you're just guessing. And various researchers, various scientists, various astronomers will plug in different guesses and say, no. Now this time we've got a really good estimate and we're going to really understand our uncertainties. And this is how they sound, by the way, in conferences. And we're going to put in these numbers and it's going to be really great. And this time we're going to nail it. At the end of the day, it's a guess. Because at the end of the day, you have to guess because we have no idea. And just because you've broken it down into smaller chunks doesn't mean you've suddenly magically learned something. You still don't know. You still don't know how common life is in the universe. Yeah, we're here. Congratulations. Are we rare? Are we common? Are we somewhere in between? We don't know. So, yes, I'm sure the press about this topic is getting the actual research statements wrong that are in the paper. I haven't even read the newspaper articles about this and the magazine or blog entries about it. I just read the headlines. I'm like, and I saw, oh, here we are again. There's another guess on how many aliens are out there. Folks, we have no idea. I don't know how many times I can say this. Also, I'll say it a few more times. We have no idea. We have no idea how many aliens are out there. If you'll remember, what was it, 6 months, a year ago, there was a big research paper that hit the news hard saying we were guaranteed to be alone because they put in a bunch of guesses and it came out that we were the only ones. So maybe we should get that research group and then the research group that are saying that there are 35, there are 36 other intelligences in the Milky Way and like put them in a room and make them fight or something interesting. It'd be more interesting than reading these papers ad nauseum that claim to have a guess as to how many intelligences are out there. That's at least entertaining. None of this is informative. Sorry, I know I'm getting on a rant, but I feel good about it. None of this is informative. This paper has not advanced our understanding of intelligence, of aliens, of estimating aliens, of finding aliens. We haven't learned anything. We haven't progressed anywhere. All we're doing is just throwing numbers on the wall. Here's my guess. Paul, how many aliens are out there? 63 in this spiral arm of the galaxy. I have no idea, folks. And neither do you. And neither do they. They being the people who are claiming to make a guess. Or maybe the research paper says something completely different and I'm way off base. In which case, my deepest and most sincere apologies to the authors. But that's what you get for writing papers about aliens. You get junky newspaper articles. I'm Paul Sutter, and this is Space Radio. This show is brought to you by you. Please visit Space Radio or patreon.com/PM Sutter to learn how you can keep this show going. And yeah, every time the Drake equation or estimates of intelligent life come up, I'm gonna do the exact same rant and we're all gonna have the exact same great time. I'll see you after the break. Whew. I need to take a break after that. Is it too dark in here or is it just me? Should I lighten it up a bit? Like, I know tone and presentation style is one thing, but also like the actual lights in here. Yeah, Battle Royale. I know I'm far away from the microphone. That took a lot of energy. A good rant. And you guys know, a Drake equation will always get me in full Kraken mode. I used to do that on Weekly Space Hangout to everyone's delight. Oh, you're a Drake equation. Okay, get out, Paul. Paul will say something interesting about this. All right, we got tons of questions here. Lots of questions. I'm going to do one caller and then I'm just going to try to blast through these. I know you guys, you space cadets, you're always so patient. Where are we? Let's do it. Timer. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got more questions ready to go and more rants right around the corner if I'm in the mood for it. But remember, you can join the conversation by leaving an online voicemail or by following the live streams. Go to spaceradioshow.com for the links. Hey, Greg, I need someone else to talk for a second. Can you just play the tape?
Hey, Paul. I got a follow-up question on cosmic voids. Yeah, I know you don't like talking about it, but I really like the analogy that you had of uh, the bubbles in the bathtub expanding exponentially. That the voids and the bubbles cause expansion and stretching of the film around the outside. But then I'm pretty sure that in one of your Ask a Spaceman episodes, you spoke about the cosmic microwave background as it travels to us on the edges of our observable universe, that as it travels through the voids, that it gets stretched out more than the light that doesn't travel through maybe such a large void. I'm just wondering, am I misunderstanding something here? Or if I'm not, why does the light stretch more as it goes through one of those voids? Cool, thanks very much.
Super cool question, Campbell Duncan. Thank you for doing a follow up about voids, the most amazing topic in the universe, which is absolutely nothing. That's why I spent a good few years focusing on in my research. I'm still involved in some void research. These are large empty patches in the universe, a place with hardly any galaxies, hardly any matter at all. And I did an episode about voids. I did an episode about the cosmic microwave background, and I made this comment that Campbell is referring to about the nature of background light that passes through these empty places, and how does the light get affected passing through the void? This is something. Are you guys ready for some serious nerd jargon action? Are you ready for this phrase? I'm going to drop it on you. The integrated Sachs-Wolf effect. Integrated Sachs-Wolf effect, ISW effect. Sachs and Wolf, two people, they figured this out. Integrated because it's going over a long time, and then effect because it's an effect. The integrated Sachs-Wolf effect. What happens is a bit of light enters a void. It crosses the first entry boundary of the void, it reaches an empty patch of the universe, and it goes from a high density region to a low density region. That change in density will, if I remember right, will give some energy to the photon because it's going downhill. It's going from high density to low density, gravitationally speaking. So the light gets more energy, it gets blue shifted. And then it crosses the void, hangs out for a while, and then it crosses the opposite edge of the void, the opposite wall. And that opposite wall, it'll be going from low density to high density. And that's like climbing back uphill. And so the light is going to go redshift and it will end up being exactly the way it started. Like if you start off at the top of the hill, then you go down and you go a little bit faster, you gain some energy, and then you run into another hill and you go up. That's the exact same height. You're back to where you started. Except we live in an evolving universe. And the voids are dynamic. The voids are growing. The voids are stretching with time. That means that when a bit of light, a photon, enters a void, it gains some energy because it goes downhill. But then the void grows. The walls get thicker. The barriers get higher. The contrast between the low density parts and the high density parts increases. So by the time the bit of light leaves, like millions or billions of years later, it now has to climb a higher hill than when it started. And so it loses even more energy. The growth of the void sucked some energy out of that light. And this is one of the ways that we can actually see the existence of dark energy and the expansion of the universe through this integrated Sachs-Wolf effect on the nature of light that passes through voids. But that only works if we live in a dynamic, evolving universe where the voids are getting bigger. There you go. Moving on to some Space Cadet questions while we still have time. Edward Hinton is asking, is strange matter a theory or real? And if real, could it be fast radio bursts? Lots of new stuff about fast radio bursts recently. I will talk about strange matter. Strange matter is a real thing. Strange matter is matter, a hypothetical form of matter that is made of a particular kind of particle known as a strange quark. Why do we have particles known as strange quarks? Not today's episode. Just know that there is a kind of particle known as a strange quark. It is theoretically possible, but we have not proven it or demonstrated or found it, that strange quarks can bundle together to make what are called strange stars. Strange stars are basically like neutron stars, except a little bit denser. They really behave in a lot of the same ways as neutron stars. We don't think they're responsible for fast radio bursts because in general, we kind of don't think strange stars or strange matter clumps exist, but we're not exactly sure. Moving on to Larry Gaskamp, how is it that stars in a galaxy appear to be evenly distributed and with such incredible distances in between? So stars inside of a galaxy are anything but uniformly distributed. Sure, when you zoom out to a panoramic view of a galaxy and then you take a big chunk, like if you look at something like 10,000 light years on a side, and you look at how many stars there are in that chunk, and then compare it to another chunk that's 10,000 light years on the side, and another chunk that's 10,000 light years on the side, it'll be basically the same amount of stars, but that's because you're looking at scales of 10,000 light years on the side. It's big enough that things look pretty average. But within that 10,000 light year chunk, there's going to be slightly more stars in the arms than between the arms. There will be clumps. There will be associations. There will be globules, globular clusters. There will be regions of very high density star formation. There will not be regions of very high star formation. If you go to the core of a galaxy, it's way more dense than the arms. The arms themselves are way more dense than anything above or below the disk. It's like a city. If you look at a big enough chunk, any one section of a city will roughly look like another chunk. But once you get down to the neighborhood level, it's different block by block. Another question, Road Trip Ventures on YouTube is asking, is the growing atmosphere of Antares the ultimate fate of our sun? Antares is a red giant. I believe it's from a star much more massive than the sun, but ultimately our own sun will turn into a red giant in about 4.5 billion years. Have fun with that. Moving on to Tom Bach, since every object in the universe has different gravity, does that mean time passes differently literally everywhere, just as it does on Earth based on proximity to Earth's center? Yeah. Time is relative, folks. No clocks agree. Everyone is moving at different speeds in different directions with different accelerations and with different gravities here and there and everywhere. Sure, you can find two clocks and synchronize them if you can find them in the exact same gravitational environment and speed. They can be synchronized, but in general, because gravity is different everywhere, time is different everywhere. No one is going to agree about the evolution of time in our universe, and that's just the way it is. But we can all agree that despite all these amazing questions, we're almost out of time on today on Space Radio. But before we go, it's time for the blue shift. Woo! This is fun. Nancy, I'm going to post a link to a launch party. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. And a couple things I want to talk about. One is a launch party. Finally, my book, How to Die in Space, came out on June 2nd. I've partnered with the Boston Museum of Science. We are going to host a virtual launch party on Tuesday, June 30th at 7 p.m. It's free registration. The link is in the show notes at spaceradioshow.com. It's also in the chat if you're following along live. It's Eventbrite. You just got to register so we know how many people are showing up. I will be doing a virtual book signing, so you can buy the book book off of my website, and then I will sign it live at the end of the presentation. I'm going to be doing a talk. I'm going to be reading a little bit from the book. I'm going to do viewer Q&A, which you know is always my favorite thing. It's going to be a real party. And I would say so, especially because I'm there, and Boston Museum of Science have always been really great partners, and they know how to throw a party. I've done an event with them last month, and it was an absolute riot, and I'm really looking forward to this. As you know, I've been paying attention to, or trying to shine a light on the situation of Black and minority physicists in the community and their growth as students and as researchers and professional researchers. And I do want to point out one organization that has been working hard for decades. I'm going to talk about the National Society for Black Physicists. This organization was founded back in the 1970s by a few African-American physicists. At the time, they were like the only ones. They have been advocating for growth and outreach to get more Black students into the pipeline, to make physics and astronomy a more attractive career choice for them, to work out what are the subtle biases that people in the physics community exhibit that might make it an unwelcome environment for Black or minority physicists. And how can we change that? How can we grow awareness? How can we start to shift these demographics that I talked about last week, of how there are very, very few Black physicists, and it's not because of a lack of desire or capability. Something is going on. And if you would like to donate, you can go to their website. That's nsbp.org, stands for National Society of Black Physicists.org, and you can donate them and help them with their mission. Thank you, Nancy, for putting up the link so quickly. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by you. Please visit patreon.com/pmsutter, or if you wish this week, go to nsbp.org and send your contribution there instead. Thanks to Greg Moebius for producing, Nancy Graziano for wrangling the Space Cadets, and all the fine crew at WCBE Radio 90.5 FM in Columbus, Ohio, for making this show possible. Catch the live stream every Thursday at 8 p.m. Eastern. Visit spaceradioshow.com for all the links that you need. And of course, thanks again, Space Cadets, for listening. See you next week. And remember, science is for sharing. End of transmission. Everything I understand about NSBP is great. You really should contribute as we bring over some cheese here. Let's bring in Greg. Greg, if you don't know, everyone, Greg is like my producer. He lives hundreds of miles away from me, and I send him MP3 recordings or wave recordings of this, and then he turns it into a radio show. We used to do the show together. When I lived in Columbus, he was in a booth. Well, I wouldn't say together, because he would just read the newspaper and, I think take naps while I recorded the show, which is exactly what he's doing right now. So in some ways, things have never changed. Today's cheese looks very, very lovely. You know me and goat cheese. This is an organic garlic and herb goat cheese from Wellesley Farms. Looking great. It is dark in here. I gotta get some more light. Okay. This cheese does promise a 100% money-back guarantee, which is, I think, exciting. This is from Westboro, Massachusetts. Oh, no, it's distributed by BJ's. I have no idea where this cheese is from. Wellesley Farms, presumably somewhere in the United States. But they are confident in their cheese-making abilities to the point that if I don't like this, I'm getting all $2.99 back. Yeah, it was on sale. Smells great. It's hard to go wrong. I'm going to eat it right off the knife because I don't have crackers today. Very creamy, as usual for goat cheese. Yeah, I love goat cheese. Garlic and herb. It's it's very garlic forward. It honestly it honestly tastes like a garlic dip. That's how creamy it is. It's not a bad thing, but I feel like I don't even know if this is real goat cheese. There is a tanginess, but they could have just taken some cream cheese and mixed in some garlic and like a packet of ranch dressing seasoning and called it a day and probably would get away with it because once you add creamy, herby, and garlic, kind of hard to go wrong. So yeah, this is fine and I'm going to eat this whole thing, but it's not necessarily special. So I think I'll keep it. I think I won't demand my money back because I am satisfied. I'm minimally satisfied. I'll see.